So, very interesting topic on capacitor. So, if you've been doing capacitor for some time now, one of the common mistakes that happens in this very conceptual problem is that two capacitors are connected with opposite polarities. And the question is, what is the new charge on the system? So you bring two capacitors which are charged and then connect opposite polarities. So let me show you where the opposite polarity is. So you have these two capacitors, right? But the way they're connected is the positive is connected to the negative. The pitfall is most of the students believe that this is a parallel connection because it looks very similar to a parallel connection like this, right? In a parallel connection, you have the plates of like polarities which are connected to each other. And there is a battery to maintain the common potential, across plates of both the capacitor. But in the case of the situation number one, which is this, the capacitors are, opposite polarity, the way they're connected. And in this case, the charge redistribution happens. And the charge redistribution happens to an extent that the potential of the plates becomes equal. At that point, the charge stops flowing between the two capacitors. So just because the two capacitors are connected in a particular manner, should not lead to the conclusion that these are parallel capacitors. Opposite polarities are connected means charge redistribution will happen until the capacitors achieve a common potential. I hope this helps. You would see some numericals in which this situation is there. So don't get confused with, between parallel plate capacitors and the capacitors where the plates are connected in reverse polarity. Thank you very much.